Hello everyone. Now I would like to discuss about G by T ratio of satellite communication link. G by T ratio of satellite communication link. Here G by T ratio is nothing but gain to temperature ratio. Gain to temperature ratio. Here to define the gain to temperature ratio, here we already have the satellite link equation. Satellite link equation is nothing but the power received from the satellite to the Earth station. Power received from the satellite to the Earth station, that is PR. PR is equal to PT GT GR. PT, here PT is the transmitted power from the satellite. GT, GT is the gain of the transmitting antenna. GR, GR is the gain of the receiving antenna. And R is the distance between the satellite to the Earth station. Sorry. And lambda. Here lambda represents the operating frequency, that is wavelength of the operating frequency. So here we have this equation. This is the equation for this particular equation is the power received from the satellite to the Earth station, which is called as link equation. And we have another equation, that is carrier to noise ratio, is C by N is equal to PR GR by K into TS into BN into GR. This is carrier to noise ratio. This is nothing but signal carrier power to the noise power. So carrier power is nothing but PR, power received power, and GR is the gain of the receiving antenna by here K is the Boltzmann constant, and TS is the system temperature, which we had already seen, and BN is the noise bandwidth, and GR is the gain of the receiving antenna. So here GR will get cancelled, so that the carrier to noise ratio finally we are obtaining is PR by K in TS into BN. So in this C by N, here we are substituting the received power equation in here. So here we are substituting this equation. So, and finally rearranging this equation. We will rearrange this equation. So here we will get C by N, carrier to noise ratio, is equal to PT GT by KBN into lambda by 4 pi R whole square into GR by TS. Now this GR by TS, nothing but gain of the receiving antenna by system noise temperature TS. GR is the gain of the receiving antenna. Sorry. Gain of receiving antenna. And TS is the system noise temperature. So this particular term GR by TS is usually it is quoted as G by T in decibels and can be used to specify the quality of the receiving Earth station or satellite receiving system. So this particular term is used to specify the quality of the receiving Earth station. Since this increasing in this parameter GR by TS, will increases the C by N ratio. If C by N ratio is increasing, we can say that the system is effective. The system is effectively working.